Hello, this is Dr. Baxley. This is a quick video to help you work on limiting reactant problems. I urge you to print this page out and make sure you work the problems on your own. It's really important to practice on your own, especially this type of problem. This is one of the most important types of problems in general chemistry. And if you can do this problem in Chem 201P, you'll be doing great in Chem 201A. In this particular question, you're being asked about the maximum amount of a solid that can be formed from a reaction of lead-2 sulfide with oxygen gas. You're also asked to determine which reactant is limiting reactant, and how much of the reactant in excess is left over. One question to ask yourself, is this a problem that involves limiting reactants? The answer is yes. How do you know this problem involves limiting reactants? In this particular case, you're given a mass of one reactant, the 44 grams of lead-2 sulfide, and a mass of a second reactant, 19 grams of oxygen gas. By looking at this is your clue that this is a limiting reactant problem, that there are two fixed amounts of reactants. The first thing you want to do is start with a balanced chemical equation. In order to solve part A, determining how much mass you can make from the two fixed amounts of the reactants, I suggest that you start this problem and work it just like you worked the other stoichiometry problems, where you had one reactant and an excess of other reactants. It's a tool that you've already learned, and you can use this tool again to solve this kind of problem. In this case, you'll have to solve for how much mass you can form from each of the two reactants separately. Pick one of the products. In this case, you've already been asked to calculate the mass of the solid that can form, so picking that solid will be great. You can pick any other product to determine the limiting reactant too, but just be a little bit strategic about how you're going to solve the problem. I'll show you how to solve the problem for mass of the lead-2 oxide that can form from both reactants. Once you solve for the mass of the product possible from both reactants, you can look at the two numbers. From the oxygen, 88.4 grams of the lead-2 oxide is possible, but from the lead-2 sulfide, only 41 grams of the lead-2 oxide is possible. What this means is that after 41 grams of the lead-2 oxide forms, all of the lead-2 sulfide runs out. There are no more lead ions to use. And so this is the maximum possible amount of the lead-2 oxide that can form. If there was more lead-2 sulfide around, there's enough oxygen to make the 88.4 grams of lead-2 oxide. So that means there's plenty of extra oxygen left over. This should help answer the next question, part B, which reactant is limiting? We can tell from the above calculations that PBS is the limiting reactant, often abbreviated LR, and that O2 is in excess, meaning that there's lots of extra O2 around. Now we can move on to the last question, part C, and calculate how much mass of O2 is in excess. Knowing that 41.0 grams of lead-2 oxide can be made from the 44.0 grams of lead-2 sulfide, we can calculate how much of the oxygen is left over in terms of mass. One useful way to think of this is to know that if we can remember how much oxygen we have to start with and subtract away how much was used, this will tell us how much is left over. We know what we have to start with. We know it's 19.0 grams of O2. In order to calculate how much is left over then, we'd have to figure out how much was used in the reaction. We can do that through good old stoichiometry. We know that the reaction stops at 41.0 grams of lead-2 oxide. At that point, we could calculate how much oxygen it took to make the 41.0 grams of lead-2 oxide. By relating the mass of lead-2 oxide that forms to the number of moles of O2, and then to the number of grams of O2 that would take to make the 41 grams of lead-2 oxide, the amount of oxygen used can be determined. Going back to our calculation plan, we know that if we have the amount to start, the 19.0 grams, and subtract the amount used in the reaction, now we know that's 8.82 grams, we can then calculate the mass of oxygen left over after the reaction is finished. This calculation gives 10.2 grams of oxygen left over. We can see if this makes sense. In the first part of the problem, we calculated that from 19 grams of oxygen, we could make 41 grams of lead 2 oxide. If we calculate how much is used, that's about 8.8 grams, leaving 10.2 grams left over. It seems like about half of the oxygen has been consumed. Looking back at the limiting reactant calculation, we can see that 41 grams of lead 2 oxide were possible from one reactant, and 88 grams of lead 2 oxide from the other reactant. What this tells us is that we could have made almost twice as much lead 2 oxide from the oxygen gas if there was enough lead 2 sulfide present, meaning that we used only about half of the oxygen gas to make the 41 grams of lead 2 oxide. And that is indeed what we found in this calculation. I hope this has shed some light on the limiting reactant problems.